I want to finish the note. So this is where we're starting, page 6. Now, I will say this. What I want to do for this on page 6 is think about what things are looking like here on these problems. Now, at the top, or near the top of page 6, we've already seen fractions with radicals. And all we really have to do is just 54, right? We could just simplify that fraction. But look at the bottom here, and on this first one, x on top, 2 on bottom.
No.
You can't do it, right? Now, you will see fractions maybe here on this. June, Cole, would you guys mind closing your computers for me? You might see something like this here. If you're looking at a problem, just because it's a fraction doesn't mean that it's actually wrong, but maybe you see something like this, 3x squared and the square root over 27x to the 6th. Could you reduce that fraction? 3 on top, 27 on bottom? Yeah, you could make it a 1 and a 9. What about the x's? Do those reduce?
Yes. Bottom.
So don't we have 4 more on bottom?
I'm not sure. I think so.
2 on top, 6 on bottom. Now I could simplify each of these here by just making it a 1 and a 3x squared. So I'm not saying you can never have a fraction. But what I'm saying is you will never, in this class right here, have a fraction like the bottom here where it doesn't reduce. All right, where it doesn't reduce. There's a process called rationalizing the denominator. We are not going to worry about that this year. Okay? We are not going to worry about that this year. So, like here at the bottom of page 6 and the top of page 7, we are not stressing about those right there. What I do want to get into is defining what a like radical is halfway down page 7. On page 7, it's asking for like same index, and that was something we really focused on. I guess that would have been Wednesday. But they also have to have one more feature. Not only do the indexes have to be the same, but the radicands have to also be the same. Kinsey, remind us what a radicand is, at least part of that? Yeah, whatever. Now, it doesn't have to be a number, but yes, whatever is underneath. It could be a letter, it could be a number, right? They have to be like radicals, right? So recall that a radicand is just whatever is underneath. Now, we could go through some examples of like radicals with numbers. We could go through some like radicals with variables. Here is an example, square root of 7 and square root of 7. Here's an example, 3 square root of 5 and square root of 5. Those right there are not like radicals. Those are not like radicals with that. So when we're looking here, keep that in mind, please, when you're thinking through some of these problems. Are they like radicals, or are they not like radicals for that? Like radicals with variables, you could see, hey, I have the cube root of x squared and the cube root of x squared. Stephen, feel free to keep the cap on that, please.
Sure.
What are like radicals without variables? Or with variables, excuse me? I could see the cube root of x and the fourth root of x to the fifth, right? Those are examples of not like radicals with there. So let's go through and analyze this here. Letter A. First one. We're just going to ask ourselves two basic questions. June, if I look at this one here, do these two have the same index?
No. They do.
Yes, I agree they do. What number did I just circle? I circled a 2 for both of them, correct? So yes, they meet the index part, right? Dylan, what about the radicands? Do they have like radicands for the first one?
Yeah.
You bet, right? So these are like radicals. So when you add or subtract them together, the index and the radicand, they do not change. Just like if you were adding 3x and 4x, it stays x. Maybe there's a number in front that changes. So, Allie, if that's true, we're just combining these numbers. What do I do with 3 and 2 on this specific problem? Positive 1. Students, do I really need the 1 in front? I don't, right? It's not wrong to put it. But so many times it's just like that but that understood number there. What do you think about letter B? Quick, what do you think? Yay or nay?
No. No.
No, I agree. Notice the indexes are the same, but this right here, these are what do not. Let me do it. Now, I will say this. Yes, it's because of the 7 and the 5, but notice how, could I have even added an x and an x squared together?
No.
No, so that would be another thing that prevented it. So when you say, hey, add or subtract it, you could say not possible. You could say already simplified, right? So you can kind of classify that as a couple of different ways. Letter C, try that on your own. What do you think?
Easy. Got it.
Did you change the index in your answer? Did you change the route? Hopefully not, right? Neither of them change, but just the number out in front does. All right, next page. The top 3 are just more of what that is. Just not possible, not common indexes. This one right here, you can add it to make 7x square root of xy. Again, the x's do not change, just like they haven't for so many times. And then again, letter F, we're just saying a quick yes or no. They do have common indexes and common radicands. So we're just combining like terms here. Now let's transition out of this. One thing that we notice is that when we're taking a look at it here, the 2 that I did simplify, I had the same thing underneath. But let's look here at example 2. Do I have the same radicand for any of the 3's?
No.
So you might say, hey, I can't do it. But what I want to challenge you on is right here when you're looking at this, that I couldn't even simplify any of them. Both of these and the ones on the previous side here, they were already simplified as much as I could. But that's not the case here. How would, Isaac, I simplify the square root of 12? Well, we could break it up into 2 numbers, right?
Oh, yeah.
What 2 numbers would it be?
The 2, 3.
Yep, 2 on the outside, 3 on the inside, right? What about 75? Sydney, how would 75 simplify? 5 square root of 3. Well, minus square root of 3, right? Now, when I simplified it, now do they all have the same index and radicand?
Yeah.
They do, right? So we know the square root of 3's got to be there. But what's the number in front?
No, nothing, so it's 0.
2 plus 5 minus 1.
6?
Wouldn't that just be 6, right? We're just adding or subtracting the numbers in front. You with us, Carson? Good thing there's always another game for him, huh? Can you imagine? What if I always thought about this. What if you only had 5 fouls for the season? Like, wouldn't that be just a crazy rule to have? You'd play a lot differently, that's for sure. All right. B. Right here. They all have the same index. Let's try and simplify them. Now, students, recall we really worked hard at trying to do this on the last class. You may prefer one method over the other. Maybe you like to see which of those salmon or orange colored numbers on the cubes go into each of these, or we could try a factor ladder. If we try a factor ladder, we should always start with 2. Right? 2 is the smallest prime number. And Cole, just by looking at a number, how do we know if 2 goes into a number? 250. I'm going to try 2. How do I know just by looking at a number if 2 goes into it? If it's even, right? 250, even, so we know 2 is good to go. So we're going to go 2, and that's 125. Clearly 125, not even. So 2 doesn't work. What should the next prime number be that I try?
3?
Yeah, 3. Right? I want to at least acknowledge the 3 here. It may or may not work.
It doesn't.
1 plus 2 plus 5. That's 8. 3 doesn't go into 8. So 3 does not go into 125. But, as so many of you said, let's try a 5. Do I see 3 of the same number because that's the index right there? Isn't that the 5? And isn't the 2 right here the leftover? So that's how it simplifies right here. And that makes sense because isn't 250 really 125 times 2? 125 is up there. Same idea, now 54. We know 54 is even, so 2 goes into it. 27 times. And that makes a 3, and a 3, and a 3. Do I see 3 of the same number here?
Yeah.
Again, students, this is something that you're going to have to practice when you do this. Let me be this. This is 7A, but none of what we're covering today in 7A will be on the learning check. Just the things that we talked about on Wednesday. No, you would say, so if there's two or more groups, you multiply those numbers together to put them on the outside, right? So if it was a group of 5s, and I know I'm making this up, a group of 2s, that would be 10 on the outside there. Same idea if there's multiple numbers left over on the inside. Add them back together on the inside. Last number is 16. Well, it's even all the way through, so it's really just 2 times 2 times 2. We can see that common number with the leftover right there. 54 was really 27 times 2. 16 is 8 times 2. Now I have, again, I still have common indexes and like radical.
6.
How'd you come up with 6, Stephen? You're right, by the way.
I did my math. 5 plus 3 minus 2.
Is 6 right there.
Yeah.
So, just because it doesn't look the same, maybe see if you could simplify it first before that actually happens. All right, next thing here. These are the last two examples, example 3 and 4, that we're going to cover. And what I want to ask is, this idea is exactly what we did when I saw these two. Word. Math, careful, 4-letter math F word, that a lot of you use to do these problems. You guys, you're saying bad math F words right here. We're just distributing, or whatever 4-letter F word you were just saying.
Not bad.
Okay. I'll give you that.
I know. I'm being serious.
When we look here at distributing, we're just doing it the same way. Now keep in mind, at least the two numbers I've connected by the red here, that is just 20. But when we get into multiplying numbers with and without radicals, we can only multiply the numbers together if they're both on the outside, or only multiply numbers together if they're both on the inside. So on the outside two, the two that I've connected by, and there's only one number on the inside, so that is 16 square root of 2. Not that it has to be this next order, but I'm going to do the purple next. The 2 on the inside. Again, we have two numbers on the outside and one number on the inside.
That would be 26. Square root 2.
Before we do that, though, let's just finish multiplying, because remember, when you would distribute, you'd have 4 different things. Same idea here. But notice on this last one, I have two numbers on the 8, and I have two numbers on the inside.
What the?
Not that you have to do it in this order, because Stephen is correct. You do have to simplify and combine the two numbers, or terms, in the middle. But how would I simplify that last one? You have to, yes. It's not really 8 times the square root of 4. It's really 8 times just 2, right? Not the square root of 2. Remember, what is the square root of 4?
2.
It is just 2, right? It doesn't have the square root sign on it. So really, it's just 8 times 2, or 16. So now, let's combine some like terms here. And to Stephen's point, we can, like I said, combine the middle two right there.
Yeah.
There it is.
Wait.
So, did it make sense why I simplified it up here to the 8 times 2?
8 times 2
is
16.
16 right here. But don't I have another number radical? Another like term with the 16?
Yeah, no radical, so it's just 20 itself. So
20 and 16 is 36. Great job, man.
Thanks.
All right, try letter B. Do it on your own. See if you can use it on this. Since you don't have to have these written in this order, but you do need to have all 4 of these right here, because then I can reorganize them as needed, right? Again, see if this last one simplifies, or any of them really. It's really 8 times 5, or 40, 6, and 16 of 5. Really just a variation of what we've already seen, and to be honest with you, a lot of times it's already seen, but I don't really want to get into this, but this word is the reason we're doing that. That word, a conjugate, Again, if we would have done more work with imaginary numbers, if we would actually have done those problems on the previous page that I said, hey, let's skip them, or if we were ever going to do some of these right here, we would use this idea of a conjugate. But what I really want to ignore is, again, just multiplying them, right? But what is going to happen, these two that were conjugates together? The x squared minus, niner. But did the middle terms cancel out here? That's what's going to happen when you have the exact same parentheses except for the sign in the middle.
I need to find this.
25. 5 square root of 7. Now be careful on this next one. I guess we haven't seen this technically yet. Isn't it negative 5 square root of 7? There's a negative sign in front of that square root of 7. And then last but not least, square root of 49. Which one of those simplify?
49.
To what?
7.
So keep in mind, students, you're right there, right?
Yeah, so negative 7. Right now.
What about right here? What happens with those?
They're 0.
They cancel or simplify out, right? So really what I have is, since these are
So that's 18.
simplifying out, 5 minus 7
It's 18.
or 18. Try that last one here, letter B. Do the last one. Again, it takes some time. Try it here and see what happens.